Hi, and welcome to Calculus Examples. I'm Dr. Finch. Today we're going to look at the volume of a right circular cone with height h and base radius r. So the object that we're looking at, I do love my pictures, is going to look something like this. It's like a little party hat or something. And we have radius h or radius r and height h. And notice we said right circular cone. I know that sounds a little bit weird. When we talk about a right circular cone here, it means that you don't have something that looks like an ice cream cone that fell on its side. That angle that we have at the bottom is not going to be anything but a 90-degree angle that we see right here. So we have to have a 90-degree angle for a right circular cone. Some background information on cones. So, and this is just as an aside, I'll do this here. We know that if we can kind of infer if we have a cylinder, our volume is going to be the volume. So we take the area of a circle, so that's pi r squared, and then we give that circle height of h. So the volume of a cylinder is going to be pi r squared h. When we talk about the volume of a right circular cone, is actually 1/3 of the volume of our cylinder, which is kind of interesting. It's like you chopped off 2/3 of the cylinder, you just kind of willed that away, and all you're left with is this cone in the middle. That's the volume that we should have as our outcome, but of course, we want to use calculus in order to figure that out. And to do that, we are going to chop our shape up into nice things that we can use calculus to add up. As we chop up our object, you notice if you do slices like this, we are going to have discs that we're working with, which we do know how to work with because that is the circle with a little bit of height. So we know what to do with that. I am going to do one more thing before we get started. I'm going to tilt my cone onto its side. Actually, let me do this because I want to do this as a dx instead of a dy. You don't have to. Either way is going to be just fine. So I'm going to put, there we go, there's our line, and we have our little, this distance right here is our radius. This one is going to be our height. Actually, it really doesn't matter, but I'm gonna rotate that around our x-axis, so that's gonna give us our cone shape instead of rotating around the y-axis. What that means in difference is that when we chop up our shape, we're going to chop it up like this and then rotate that around the x-axis. So our discs are going to look something like this, and we are going to have a change of x is going to be our little bit of height in there, and then we have a radius of some sort. So we want to know what the volume of a slice is. That's going to be pi times our radius squared times the change of x. Now, the radius of our volume of our slice here is going to change as we move along this line right here. So this line, we need to know what is the equation of that particular line that I've highlighted. And we can figure that out. That's the nice part, is because it's a line, we know it has 2 points for sure. Our first point here is 0, comma r, because our radius is r, so we know that's r above. And our second point down here is h, comma 0. So with 2 points, we can get the equation of this line. Okay, and to get the equation of our line, we need a point and we need a slope. So this is stuff that you probably used in pre-calc or college algebra. It may have been a little bit. So we'll just go through this again. So we have these 2 points, and we're going to use these points to figure out our slope, which is going to be our change in y over our change of x. So our y values, we're going to do r minus 0 over 0 minus h. Remember, when you're taking your change of y over change of x, whatever value you start off with here, so it starts off with this r here, you have to start with the same exact point on your denominator. So we have to start with the 0 down here and then subtract h. Otherwise, you're going to be off a little bit. So, and I'm going to pop that negative sign up top. So we have negative r over h. I'm going to call that m for our slope. And when we write out our equation, y minus y naught is equal to m x minus x naught. And it really doesn't matter which point we use. Here's our slope. I'm going to use this one for our point. So y minus r is equal to negative r over h of x minus 0. In other words, y minus r is equal to negative r over hx, or y is equal to negative r over hx plus r. So if we go back to our picture up here, you'll notice that is the equation of this line here, which tells us the radius of our slice. So if we pop that back into our equation, the volume of our slice is going to be pi times negative r over hx plus r squared change of x. So there is the volume of our slice, and then we are going to put this together to get the volume of our cone. And if you enjoy explanations like this, subscribe. I'll be doing Calc 2 problems all spring. So the volume of our cone, all right, I'm going to go back to a darker color here, is going to be, we are going from 0 to h because we're along the x-axis. And then we are going to pop in that equation, negative r over hx plus r squared dx. And now all we need to do is integrate. And I say all we need to do, but this is going to take a little bit of time. I'm going to pop out that pi because it's a constant, so we can just move that to the outside of our integral. On the inside, let's actually, we're going to square this out. So we are going to have negative r over hx quantity squared plus 2 negative r over hx times r. So don't forget that middle term when you square things out. Otherwise, you are going to have big problems. That is one thing that sometimes gets left behind, unfortunately, as we work these problems out. All right, I'm going to distribute that squared up here. We're going to distribute it across everything. Negative r squared is that negative value is going to disappear. So we're going to get r squared, h squared, x squared minus, and then we're going to have 2r squared over h because there are 2 r's here. So I'm going to pop those two together times our x plus r squared dx. All right, so we've cleaned up our equation, and this is kind of an important step. I know that we haven't actually changed anything. We haven't actually evaluated anything, but just taking that time to like put these r's together, put the negative sign out front in this middle term, that's going to make it a lot easier in the end. So I know we're always in a rush to solve these things. Taking their time can make a very big difference when we're working through this. Because now we are set to integrate, and we're not going to have extra stuff that we're worrying about as we integrate. So add 1 to our power, divide out by our new power. You'll notice I added a little bit of space in front of the x so that we could put that number in there. I'm going to do that for our second term as well. We have minus 2r squared over h, and then we're going to add 1 to our power, divide by our new power, plus r squared, add 1 to our power. So that's going to turn into an x, and we are going from 0 to h. You'll notice right now that our 2's are going to cancel in that middle term. And we have a 1/3 that's popping up. So that's definitely a good sign that we're on the right track. Now let's actually put those numbers in. R squared over h squared, 1/3 h cubed minus r squared over h squared plus r squared h. And you'll notice if we plug 0 in, because every single term here has an accent, they're all going to vanish. So we actually don't even need to write that in, which makes our lives a lot better. Okay, so pi, and let's do some cancellation here. We've got 2 h's that we're going to cancel out in the first term. So that is going to leave us with an r squared 1/3 h minus, and let's cancel out, we can cancel out one of the h's in our second term. So that is going to give us an r squared h. Oh, and the last one is a plus r squared h. And isn't that cute? Because those cancel out. And we are left with, let's pull that 1/3 all the way out to the front, our pi r squared h. And that is exactly what we said we should get as our volume of our cone. Oh, that was a lot of work, but it was very beautiful and very worth it. Thank you so much for listening.